3. The topic for session 3, you need to demonstrate knowledge of main features of WANs. The learning outcomes for session 3, you need to explain the uses of WANs with respect to current practice. And then lastly, you need to explain the uses, hardware requirements and advantages of WANs. The demonstration explains the uses of WANs with respect to current practice. WANs is a wide area network. A WAN is a computer network that spans a relatively large geographical area. Typically, a WAN consists of two or more local area networks. Computers connected to a wide area network are often connected through a public network such as telephone systems. They can also be connected through leased lines or satellites. The largest one in existence is the internet. So it consists of two or more local area networks. As I've explained from my previous video, session 1 video, we've got generally two WANs. We've got two WANs connected to each other, which forms two LANs, which forms a WAN. So for instance, here we've got a LAN 1 and LAN 2 connected to the internet. So I just wanted to give you a brief description of that, to say this is an interconnection of two or more LANs. So we've got two or more LANs. We've got LAN 1 and LAN 2 connected to each other. So in this form, it's in the form of routers. So this is a LAN, this is a LAN, this is LAN 2, this is LAN 1. So there are two or more LANs connected to routers, which forms a WAN. So a network is an interconnection of routers making an internet. Let's go back to our learner guide. The definition: a wide area network is not confined to one building. The computers and the terminals forming part of the network can be spread around the world. So this can spread around the world. Let's say, for instance, we've got one office in Johannesburg, and this office is in Johannesburg, and this one it's in Cape Town, for instance. So these routers are in Europe, let's say maybe London, United States, Asia, Ghana, and so forth. So this user wants to connect to United States, for instance. Let's say here it's United States, wants to access google.com, the domain Google. So he will send his packet from his desktop, and then his desktop the packet will go through the switch, and the switch will send a broadcast to the nearest router, which the router will send a broadcast message to all the routers which are interconnected to it, and then that packet will be sent to United States, hopping from one router to another up until it reaches to the United States, to Google domain, domain.com. So let's go back to our learner guide. External communication links such as satellites, microwaves, telecommunication links, and optical fiber will be used to connect the parts of a WAN. The connection must be normally be paid for because the links are external. The internet is a worldwide WAN, and a LAN can be connected to it using a router. As I've explained here, it's a worldwide WAN. So these are just routers, which simply explains that for using this is a network basically. It's that cloud that you normally see when they demonstrate the internet. So it's just an interconnection of routers combined together forming a WAN. So it could be more than, it could be such complicated as to, could be interconnected, could be so complicated to an instance that you couldn't understand how these connect, but it's just an interconnection. Like I just wanted to make it somewhat complicated to just explain the cloud form of the internet. So this is our internet. So it's an interconnection of routers within within the cloud of an internet. So advantages of a WANs. These are similar to those of LANs, except the scale of sharing etc becomes far greater and can be worldwide. The disadvantages of WANs, again, these are similar to those of LANs, except that issues such as security become even more important, as potential hackers could break into a computer system from anywhere in the world rather than having to physically be in a building. Encryption to secure data such as financial transactions is necessary because it is even easier to intercept data. So I just want to explain the first point as to the issues such as security become even more important as potential hackers could break into a computer system. So let's say we've got this setup, this LAN. So now in our LAN we've got a banking. Let's say maybe this is our Old Mutual, for example. This is an Old Mutual environment. So here in this we've got important information for our users. So now let me set up something that could demonstrate something that has security. So yes, this would be our firewall. This would be our firewall. So yes, this is our firewall. So let's say, for instance, this is our Old Mutual. It has important information about the users that the Old Mutual has. So if we have security breaches within the environment, it becomes much more easier to secure the environment. But now if, let's say, for instance, we don't have that any security being in place, it can provide problems within the network itself, because now users from, let's say, Russia, for instance, can easily access your internal network because of there is no security bridges that are being in place within your LAN, your environment. So it's easier for them to hack your system. So that explains that, to say the issues such as security becomes even more important, as potential hackers could break into a computer system from anywhere in the world rather than having to physically be in a building. So encryption of secure data such as financial transaction is necessary because it is easier to intercept data. So yeah, those are things that you need to consider having security within your office. So let's say we have this. I've managed to to have security within my network. So I have figured out that now, since I'll be dealing with sensitive information about customers, users, because I'm now a bank institution. I'll need uh, security bridges within my network. So let's say, for instance, a user from Russia wants to access your 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 environment. He or she will face difficulties to get through your internet, your network, because now you've got bridges within your environment, so it won't be easy for this user to access even anywhere in this world. Even you, the user's internal, it will be difficult for you to access some of the certain sites within the network. For instance, let's say, for instance, you are working for Old Mutual, but now since it's locked down, so you'll be working from home. So there are services that are used for you to actually use a certain port for you to use to access your systems within the LAN environment. So even if maybe you're working from at work, you can't access certain sites because of your firewall has blocked certain sites because of vulnerability that it sees within this network. So let's continue with our learner guide. Revision points: you should be able to do the following: explain what is meant by a network and know the benefits of networking computers. Define a LAN and a WAN, and discuss the advantages and disadvantages of each. The questions is a network. What is a network? Explain what a wide area network is. State one advantage and one disadvantage of a WAN. When using a LAN, why is it necessary to have a password? Describe the software that makes up a network. Describe the devices that makes up a typical network. Those are yours for you to answer those questions. We have covered that on our previous sessions, so you could do that on your own. This demonstration explains the uses, hardware requirements, and advantages of WANs. Important terms used in networking: internet. The newest type of network to be used within an organization is an internet or internet web. Such networks enable computers or network of any type to communicate easily. The hardware and software needs are the same as for the internet, specifically the TCP/IP server and the browser software used for the World Wide Web. Because most organizations have a need for more dynamic ways to link people and information, the internet market is expanding day by day. Moreover, there is no need to adjust the network when a new user joins in. With the help of internet, all computers of an organization can work as a stand-alone systems connected to a mainframe or a part of a LAN or a WAN. B, we've got email. Email stands for electronic mail. This is one of the most widely used features of internet. Mails are regularly used today, where without the help of postage stamp, we can transfer mails anywhere in the world. With electronic mail, the service is similar, but here data is transmitted through internet, and therefore within minutes the message reaches the destination may it be anywhere in the world. Therefore, the mail system through email is excessively fast and is being used widely for mail transfer. We've got the voice messaging. It is a new communication approach which is similar to electronic mail, except that it is audio message rather than text messages that are processed. A sender speaks into a telephone rather than typing, giving the name of the recipient and the message. That sender voice signal is then digitized and stored. The system can then either deliver the message at a specific time in future, or it can be retrieved from a database by the recipient. The message is reconverted back into its analog format when it is delivered or retrieved, so that the recipient hears it as the original sender's voice on a telephone. Voice messages requires a computer with an ability to store the audio messages in digital form and then convert them back into an audio form upon verification. Each user has a voice mailbox and secondary storage, and special equipment converts the audio message to and from the digital form. The main advantage of voicemail over electronic mail is that the sender does not have to type. Voicemail also makes it easier to include people in the firm's environment in a communication network. We've got D and e-commerce. And e-commerce is an electrical commerce, or an e-commerce as it is properly known, refers to the paperless exchange of business information using electronical data interchange. Electronical mail, electronical bulletin boards, electronical fund transfer, and other network-based technologies. Electronical commerce not only automates manual processes and paper transactions, but it also helps organizations to move into a fully electronic environment and change the way they usually operate. Few organizations have recently started conducting EC over internet. The network of networks internet has also helped EC to boost up, because it is a low cost alternative to the proprietary networks. EC standards are, however, under development. Electronic data interchange (EDI) is still the dominant part of EC. Information technology has transformed the way people work. Electronical commerce has unearthed yet another revolution, which is changing the way business houses buy and sell products and services. The WAN hardware. A WAN, wide area network, is a network with a much broader reach than LANs and WANs. They span across metropolitan areas and may well span across nations and language differences. The PSTN, the public switch telephone network, or POTS, the plain old telephone system, is a WAN. And the entire internet is a WAN. A home user connection to the internet is very likely done through a WAN. While they interact with LANs, they are fundamentally different in a form and functions. The hardware required to implement a WAN link can be as simple and readily available as a modem and a telephone line. On the other hand, it can be complicated and expensive, such as satellite and transoceanic cabling. This web page will survey some of the most frequently used hardware. Modems. The word modem originally derived from modulation and demodulation. This needs to occur in order to take digital signals from or to computers and transmit and receive them over analog telephone lines. Currently, they take on an even larger variety of basic approaches to functioning. They tend to come they tend to come in two main varieties in terms of their relative position inside or outside the transmitting receiving device. Modems can be categorized as internal or external. One of the main advantages of internal modem is compactness. They are circuit boards that fit into one of the two places inside the computer: an ISA industry standard architecture slot and the PCI, the peripheral component interconnect slot. Since they are inside, you do not need to find you do not need to find extra space on the desktop, nor do you need an extra serial cable. Unfortunately, internal modems are traditionally more difficult to configure than external ones. Several things need to be set in order to ensure there aren't conflicts within other internal components. An RIQ interrupt request. This is an assigned location where the system expects the device, in this case a modem, to interrupt it when the device sends a signal. Signals that go to a processor on the same line would interrupt each other. The input output address, this is the memory location where data from the device is stored in order to be processed by the CPU. Again, if multiple devices try to use the same input or output addresses, it will inevitably result in conflicts. Vital COM port. This is a logical port number by which the operating system identifies a serial port. You must set each serial device to use a different COM port. All modem operating systems provide a means by which you can view how resources are being used. Modifying these settings depends on the modem. The following list gives 3 typical ways these settings can be changed. Dip switches. These are small switches directly on the circuit board that can be moved, and jumpers, pairs of metal pins built into the circuit board that represent an electrical contact point, configured so that a small plug is placed on the pins to complete the circuit. A software program is used to change the configurations. Many modems support the PNP, the plug and play technology, which enables the operating system to detect the device, install the necessary software drivers, detect what resources are available on the computer, assign particular resources to the device automatically. Little or no intervention is required from the user. Unfortunately, these sorts of devices require your computer's operating system to have features that are compatible. External modems have a couple advantages over internal ones. The most provide status lights, power is on, connected, and transferring data. Usually easy to configure and install than internal ones. A couple disadvantages of external modems are they require a power cord to plug into an electrical outlet rather than running off the computer's power like an internal modem. They require a serial cable to run from the modem to one of the serial ports on the back of the computer. To use an external modem, you need to have an available serial port. Most computers have 2 built-in serial ports, COM1 and COM2, with connectors on the back of the computer. It is important to remember that many other devices such as scanners, digital cameras, and serial printing devices also use serial ports. If your computer doesn't have a serial port, then you have a few options. Use an internal modem, install an expansion card in your computer. If you have a USB, you can chain several serial devices off a single port. Use make use of a UART, universal asynchronous receiver and transmitter chip, to handle serial communications. This chip comes in different types, and the type used determines how fast data can be transferred over the serial port. Drivers are software programs that act as a liaison between hardware devices and the operating system. Some modems require a modem driver that either comes with the modem or can be downloaded from the manufacturer's website. A computer may also be configured as a dial-up server or a remote access server to allow other computers to dial into it and connect over the line on the phone lines. Computers running a particular server software can support many remote access connections simultaneously. In order to do this, the server needs to have a modem bank. The modem bank allows the server to make use of a group of modems simultaneously. ISDN and DSL adapters. The device used to connect a computer to an ISDN integrated services digital network, or the DSL, which is the digital subscriber line, is often referred to as a modem. It is more accurate to call it a terminal adapter. It doesn't really modulate or demodulate signals because the lines are digital. ISDN adapters also come in both internal and external varieties. They are configured similarly to modems, but typically 128 kilobytes per second. ISDN services consist of two data channels, each running at a 64 kilobytes per second. The two data channels usually have separate phone numbers. The ISDN adapters are configured with information about the SPID service profile identifier for each channel. Each of these SPIDs consists of a telephone number, a two-digit sharing terminal identifier, and a two-digit terminal identifier. Some more recent models support automated SPID selection and don't require the admin to enter the information. The DSL adapters or endpoints are required at both ends of a DSL connection. Sometimes these endpoints are external. Other times they are placed together with an NIC, which is a NIC, on the same card. Customer premises equipment, CPE. Customers premises equipment is a generated term that encompasses several different devices. These are used for processing transmissions on WAN lanes such as the T1 lines, the T3 lines, and X28 connections, and the frame relays. This is just an illustration of the internet and the IP addresses, the machines, and so forth. So guys, we are done with our unit standard 14913. I assume we doing our activities. I assume everyone can manage to answer those activities after going through our sessions. Explain the principles of computer networks. I have a belief that through those activities you won't have any problems doing them. So guys, thank you for tuning in through this session 3, and we have completed our 14913 unit standard. So now we'll continue further with our unit standard further. Thank you for tuning in, and take care.